Good morning and welcome. And I know we're going to have a number of people watching the recording. So I want to talk a little bit about the structure of today. And then if you're watching this recording, how that is going to be a little different in how you view this and how you take in the information. So I am your host this morning, your main mathineer, Jonalee Zupanzik, and this is going to be much more seminar style this morning, much more lecture style this morning than interactive. And I know that's not what we're used to on a Saturday morning, but it's only because this Saturday session has been promised to be delivered as a recording, even if you are not here live, and especially if you are not here live. Now, here's the bonus about being here live. I want you to be able to ask questions immediately when you think of them. So let me tell you how you can ask questions today. Number one, you can put a question in the chat. Number two, you can just unmute and say, hey, this is Julie. I have a question, and just like stop me, just stop me. So because I want to direct your question to the exact teaching that I've just done. Okay. Now, if I decide, oh, you know what, we're going to answer that question in a little bit, I'll let you know that. So number one, you can put your question in the chat. Number two, just unmute and tell me, even if I'm on screen sharing, just unmute. Just say, hey, Jonalee, it's Julie, I have a question. The third way that you can ask a question is there is a capability to raise your virtual hand. So if you can find your three dots by your name, it could be if you click on the participant button, there should be a feature that says raise hand, and then it will raise a virtual hand. So that's the bonus of being on live today. You can interrupt, you can raise a hand, you can unmute, you can type in the chat. And I want you to get what you need today. It's going to be very intense, a lot of content. It's going to be very differentiated because I'm going to model for you how I want us to teach in the classroom for a variety of levels of students. This is appropriate for preschool through high school and even higher ed. And as I'm teaching certain strategies, you might think, oh, well, I teach 8th grade. She's talking about what she would do in 1st grade. But here is pro ninja tip today for consuming this content. And that is, if I say, now with my 1st grade, I do this. 8th grade teachers listen, because I will also do that same type of version with my 8th graders. Okay. So I'm going to break today also into a few categories, and I'm going to keep us very organized with those categories. What you're going to notice from today is we're going to be very niched into one piece of content. The one thing that is the biggest leverage for math achievement. That is what we're going to be hyper focused and very niched on that one thing. However, what I'm going to be showing you today is how that one piece fits into all of the categories of instruction. So that's what I mean by being very intense. You're going to get a lot of grab and go that you can take with you and use immediately. Well, unless you're not back to school for a couple of weeks. Or you're like some of the districts I coach and you still have 3 more days or 4 more days, who knows? So I'm kind of giving you these warnings at the beginning, giving people time to jump in and giving you, what are these benefits of coming in live? You get your questions answered immediately. So raising your virtual hand, typing a question in the chat, or just unmuting and telling me you have a question. All right. And then I'll monitor like when and where and how I'm going to answer those questions and what they connect with. Let me tell you what's important about asking questions, because I don't want you to feel bad about asking questions. Sometimes now I open this up. Sometimes, we get that one person, that asks like 152 questions, and it's like, okay, that person needs to stop asking questions. Okay. Regulate yourself. Typically on these Saturday sessions, people are much more hesitant to ask questions than to hijack with questions. So I'm just being real on that. Kirk, You're not. I was not talking about you. You ask the appropriate amount of questions, but I'll use Kirk as an example. You know, if you don't jump in and ask the question when it's appropriate, then it passes by and you don't make the brain connection to what you were thinking at that time. It's essential. And the reason I say this is too many people are afraid to interrupt or afraid to be rude or afraid. Please don't be afraid. If you cross the line at some point, I will tell you, like, we got a show to run here. Like, we got to move. I won't be that rude. But the point is, it's a bonus being here live. You've gotten up, you are here in person. You're probably going to stay the whole time. I mean, most people sometimes have to kind of jump, you know, in the middle or whatever. However, if you are getting this as a recording, now I'm talking to the recording people here. If you're getting this as a recording, first of all, if you've gotten through this much of the recording, I commend you, because oftentimes we will register for things, especially things that are free, just because we're going to get the recording, and then we never listen to the recording. So if you're listening to the recording right now, you have done what 90% of people don't do. So here's the challenge I have. If you're watching this recording, keep going. Keep going. You know, don't let other things distract you. You know, really consume the content today, because I promise you it is game changing. So that's a lot of the logistics for today. And I'm going to come right out of the gate telling you the one thing that is the most powerful piece of content that we can use with our students preschool through high school that's going to completely transform math achievement for our students. And that is making rectangles. Now, I'm going to use the chat a lot today, and here's why I use it for me as a facilitator. And I want you to catch this tip as a teacher, okay? As a teacher, many times we will ask a question or give a prompt or make a statement, and it's very subtle, and the learners miss out on what's exactly happening. So the reason that I'm going to use the chat in a certain intentional way today is so that when I make a statement that is important, I'm going to type it in the chat and I'm going to pause. Making rectangles. Okay, that is our focus for today. Now, you can save the chat. I'm also going to save the chat. And when I email out the recording to this session, I'm going to send you the chat as well. It can be your guide note, and you can highlight or star anything that Jonalee has said on the chat. If you print it out, you can use that to help follow along with the video. This would be a video that I want you to try to consume multiple times. And I'm going to give you 100% permission to share this video with people that you work with, people that you coach, parents, colleagues, because these are some things that are going to transcend. And I'm going to use a lot of different words today to kind of categorize our ideas. Transcending means to prepare for what does not yet exist. I believe that we have come a long way in math instruction. However, where we need to go, I don't believe exists yet in our classrooms. And you might be like, oh, Jonalee, no. I follow Pam Harris, Robert Kaplinsky, Joe Bowler, these great, fantastic, fascinating people who have really transformed math classrooms through you as educators. So we have come a long way in mathematics with the climate, the culture, the mindset. However, there's a few pieces that are missing that are going to tie together all of those resources and all of that instructional facilitation we use. That's what I want you to walk away with today. And I don't want you to miss those things. So one of the facilitation strategies I want to use is to pause, to repeat, to type in the chat, to say again some of the most essential so that you're hearing that multiple times today. All right. Kirk, I love how active you are already. I'm gonna wake everybody else up. In the chat, I'd like for you to put what grade levels you focus on, in what capacity, and where you're from. So, for example, I focus on pre-K through 12. I am from Ohio. and I am a math coach and consultant working with dozens of school districts. Excellent. Thank you, Lauren. Perfect. Hey, Ruth, how are you? Oh, it's so good to see you here. Good. Krista is one of our certified coaches. She will be able to attend to you in the chat as well. And I will expect Krista to unmute today a good portion to give her perspective. I'm going to give you a story. I was in a school district on Thursday morning, and I was doing my teaching. And I was doing my teaching on fraction, because fraction is another, like a making rectangles. There's another one called paper folding, and it has to do with fraction. We're not going to do that one today, but I mention it because I'm going to share with you the overview of all the categories, so you can kind of piece together what you've gotten today and what you still need to get. And so I was teaching on my making rectangle, or I'm sorry, my paper folding and fraction. Fraction was our big thing. And I kept saying, we do not want to use circles for fraction, especially when we're paper folding. We do not want to use circles for fraction, especially when we're working with students with disability. We do not want to use circles. We want to kind of not focus on the circles in our paper folding instruction, in these high leverage instructional situations. One of the teachers said, I have a question, Jonalee, and see, this is where I need you to interrupt me today, because I'll go on with all of these really great key points, and then I'll forget the one key point, because then people get really extreme and they're like, Jonalee said never to use circles. And that's not what I meant. That's why we need clarifying questions today. So this teacher said, Jonalee, I have a question. You say about, using the rectangles because that's going to be better than the circles, blah, blah, blah. But on our state assessments, kids are going to see circles. See, that's a great question. Right at the great time. Here was my answer to that question. It's not that I don't want us to expose kids to circles, but when we're learning about the concept of fraction and we're doing sensory activities like paper folding, like dividing up a bar model, when we're doing those instructional things to help students understand the conceptual, I'm going to say magnitude, but I'll define it. Magnitude is just how large or small numbers are. The conceptual magnitude of fraction, when we really want kids to understand fraction, just like they do whole numbers, I don't want to use circles in that delivery. Now, another category. So today we're focusing on making rectangles. Another category that we focus on is paper folding. Another category that we focus on are stimulus exposures. So if you've been on Saturday Maths, these things make sense to you. If you haven't, if this is your first time here, don't worry about some of this other stuff. But the stimulus exposures are things that are going to stimulate mathematical thinking, that we remove the noise, not the noise we hear, but lots of extra writing and stuff. Many times I'll use a release test item as a stimulus. So I'll pull a circle fraction test item. I'll get rid of all the words and just show the images, and I'll give it as a stimulus. And I'll show it to students. The facilitation that I use is, what do you see? What do you notice? Tell me about. And then I will ask them, how does the fraction representation in the circle relate to our rectangles? So you see, I'm not saying don't ever use circle, but what I'm saying is when we use circles to teach fraction, kids struggle with circles and fraction. So they're struggling with the actual material that we're using to teach the content. They're struggling with the actual material that we're using to teach the content. So that's my long story as to why it's important to ask questions right away, so that we can make sure that Jonalee doesn't give you indirect bad advice. So Sherry also is a coach. She comes to us as an occupational therapist. So she is going to be able to connect the sensory, the behavioral, the writing, the issues that kids have, students that with disabilities or have some kind of brain-based dysfunction that they can't even attend to the content learning. There's other categories of strategies that we'll pull in a little bit today, but we want to stay very, very close to our focus of making rectangles. Now, let me see where, yeah, rectangles are really the foundation for so much mathematics. We do not leverage it enough. So yes, thanks, Kirk. Thomas, welcome, coming from Canada. I don't think I know you, but welcome. Thanks for being here this morning. Oh, Stephanie, it's good to see you. Excellent. All right, perfect. So we have some upper grades, community college. This is really, really good for some of our adult learners who never really got math. So what I like to do, especially if I'm like tutoring adults that are making a career move and they have to take some kind of math placement, what I will do is I will connect almost everything I teach them in making rectangles. They see mathematics in a whole new world. Perfect, perfect, perfect. All right. So I'm going to go back and forth from sharing my screen today. As I said, it's going to be much more seminar style today. I'm going to dump you with a lot of information. I'm going to refer to some of the people that are watching the recording because I know some of those people that are going to be watching, and I'm going to point out some of the things that I know that they need. And I'm going to encourage all of you here live to jump in when you have a question. So let's set kind of a linear framework today. I'm going to share my screen. And of course, I got to move all this stuff out of the way. All right, here we go. I'm not going to go into full PowerPoint mode just because I want to make some points on the PowerPoint. And when you get this video link, you're also going to get the PowerPoint slide deck as a resource. So a PowerPoint for me is to kind of keep me in order. When you go back and refer to this video, you're going to be able to like look at this PowerPoint and have like the linear version of this. That is not necessarily how I facilitate. So some of the things in the PowerPoint, I'm going to do not in the order that they're in the PowerPoint, but they're clumped together as the same strategy. I'll show you what I mean by this as we go. So a big question today is, what is absolutely essential for mathematics teaching and learning? Well, I've already given you one of the answers, making rectangles, and that's what we're going to focus on today. I have about 8 to 12 essentials. I'm going to mention some of them today as we go, and I'm going to put them way over here on the board, just so that when this board is full at the end of today, it's going to be chunked in like categories so that you can see the big picture. You're just not going to get the big picture. So I'm going to give you an example of some of my categories right now. And the one that we're going to do today is making rectangles. So let me write some of them and then I'll tell you what I wrote. I've got this cord in the way. I got to unplug. Good. My laptop's charged. We can unplug. Now, I don't want you to worry too much about what I have written. I'm going to read it to you. I'm going to take a picture of this at the end. You will get a picture of it because it's going to give you an overview. I'm fighting with everything here today of all of the pieces and parts. So what I wrote up here is making rectangles and pizzas. Okay, so we're going to touch on that today. It's all in the same game. What we're not going to touch on today, which I may refer to, is paper folding, which actually I already did refer to. So a pretty intense fraction, decimal, percent, ratio, proportional reasoning, negative exponents. Like if you're looking at like some of that content, that goes under paper folding. Jessie and Kay is all about rate and function, solving equations, systems of equations, blah, blah, blah. So there are a few other chunks, but I just wanted to give you some to show you that making rectangles is the strongest. If it's the only one that we use to leverage our learners, that's perfect. But there are a few others. There's not 25, but there are a few others that are like this making rectangles today. But why do I keep focusing on making rectangles and what is essential? It's because if everything is important, nothing is important. So I'm going to point out some of these important aspects in mathematics that are missed in the standards. They're actually in the standards. So I'm going to tell you today how they connect with the standards, but they're very, very much missed because we don't have a good understanding of our math standards. So we must streamline our approach to instruction. Now, I'm not telling you to not use a textbook. I'm not telling you to not use your curriculum map. I'm not telling you to not do any of those things. Do everything that you do, and then bring in these pieces that I'm presenting today as nuggets over time. Okay, making rectangles. If you did some kind of exposure to making rectangles once a week, I mean, I don't know how often you see your intervention kids, if you're an intervention specialist. If I'm pulling kids for intervention 2 to 3 times a week, I'm having them make rectangles and in different variations. So this is like the perfect intervention for our most struggling students. How do we streamline? Well, I do it with these tasks, and I use these tasks over and over and over and over again. I'm going to call these reference tasks. Why do we have so many deficits in mathematics? There are many fails to our math instruction. One of the fails is finishing everything. So trying to answer every question, solve every problem, tie the bow on it. What this does to create deficits is it creates a learned behavior for our struggling students to shut down and be passive because someone else is going to answer the question. And if nobody does, by the end of class, I'm going to know because the teacher is going to tell me. That is the worst way to try to learn anything. But if we fix that fail by finishing everything, by leaving some things unfinished, leaving some prompts and questions unanswered, and I'm going to do that to you today. Leaving things unfinished is one of the fixes. Coming back to it later, not the next day, but maybe the next week, is going to give time for students to subconsciously continue to process. Because now these kids that struggle are going to be like, okay, but you didn't answer that question. You know what? It's okay. We're not going to answer that one today. Whether they consciously or subconsciously think about it, they're going to be stewing on that. See, their processing stops. We actually create processing problems for kids because we finish everything. But if we leave some things to linger, subconsciously, they're going to continue to process and they're going to buy into the content. They're going to attend to the content much better because they're going to be working their subconscious the whole time. I'm not going to give you all the fails, but I'm going to give you a couple more. Number 2, another fail of our instruction is teaching one thing at a time. Now, I'm going to give the example with making rectangles. Making rectangles is not a math unit. Do I need to stand up and say it louder and slower? Making rectangles is not a math unit. Okay, John Lee's given us this making rectangles. I'm going to do that as my 3-week unit in February. No. So one of our fails is teaching one thing at a time, one chunk at a time, one unit at a time. I'm not saying don't do that, but don't do it with making rectangles. Okay. Because making rectangles actually spans all of your units, all of your chapters. Making rectangles has a place every month of school. Making rectangles has a place in every unit that you teach. That's how powerful it is. And if I teach making rectangles as a unit, as a 3-week unit, that's only considered really one interaction. Here's another fail of math instructions in math instruction. We're not giving enough interactions over time. Here's what I mean by that. Our gifted kids need 1 to 2 interactions with content before they know it forever. That's truly gifted kids, like very high IQ. That's just the way the brain works. I'm just giving you facts here. I'm not trying to debate like the brain or anything. Like it's true. Like a truly gifted kid, you can give them something 1 to 2 interactions, and they will know it forever. All right. So bright kids whose parents think they're gifted. Okay. I'm not being, sassy. Whoops. I'm going to get rid of this. Bright kids might need 5 to 7 interactions before they know it forever. Bright kids are typically kids that play the school game. They are what I sometimes call our false positives. I call them our quadrant 2 kids. I'm going to be making a lot of references to some of my terminology from Making Mathinaires. One of our action steps last time was to go to Amazon, purchase Making Mathinaires, write a review, send me a screenshot of it, and you get some free stuff. Do a book study, you get the free facilitation guide. Order 10 books, you get 10 more. So, hey, Making Mathinaires, get that, start your book study at the first of the year. But when I say quadrant 2, that's described in Making Mathinaires. But anyway, these bright kids who play the school game, who memorize well, who innately work hard. I mean, really, that's part of the reason for a lot of their achievement is they work hard. If we give them something out of context, which is really that fail of teaching one thing at a time, we never really give kids things out of context. And so our false positive kids, our bright kids, our kids that play the school game, that's why they're false positives, because they tend to show achievement that may not really be there if we give them something out of context. So one of our fails with teaching one thing at a time, the fix to that is to drip things like making rectangles over time with space in between. So those are some of our fails of math instruction, and those are some of the fixes. All of what I'm going to teach you today falls under the umbrella of teaching smart. Teaching smart. Now, we can teach smart in math, but we can teach smart in all other content as well. Here are some categories that I'm going to divide things into today to help us understand what is the big framework. And again, all of the examples I'm going to give you are making rectangles. When I follow up, you're getting you're going to get an amazing package today of resources. If you're listening to this recording with the email you got with the link of the recording, you will also get this slide deck to refer to. You will also get this PDF. So will all of you that are watching this now. I'll get you in your follow-up email. Make sure you look in your spam email. You're going to get this PDF that describes what SMART is. But right now, I'm going to categorize all of the different instructional categories. See, we think we're coming today to learn content, making rectangles. Well, kids can't access the content unless we have other instructional facilitation that is non-academic and non-content. Now, that's not the focus of today, but again, oftentimes when we're teaching mathematics, we're like, okay, here's my unit I'm teaching right now. I'm teaching linear function, or I'm teaching area. Let's go with something a little simpler. Area, okay? Nothing veers me away from area. Everything we do for 3 weeks every day is all about area. When we zoom in that much, which I'm going to zoom in today on making rectangles. So I'm not saying don't do this. I want us to zoom in and get really focused when we teach our units. Throughout that unit on area, we must zoom out so that kids always see the big picture of where area fits. That's what I'm doing to you today. We're niched into making rectangles, but I'm going to keep zooming out so that I can show you where making rectangles fits. Where does making rectangles fit in the SMART framework? Sensory is one type of instruction. Sensory is about movement. It is about hands-on. So when I say making rectangles, I literally mean making rectangles, making with hands-on with blocks. So part of our instruction has to be sensory. So I don't want you to miss that today. So even though I'm going to be teaching the content, I'm going to be showing you ways to help students utilize all of the senses. So there are some non-content sensory pieces as well. Now, I'm not going to have Sherry jump in yet. However, I'm going to have Sherry talk a little bit today. Perfect. Sherry's putting some notes in here because Sherry, as an occupational therapist, has many of these non-content, non-academic 30-second brain-based sensory approaches to getting the brain ready to learn. Sherry, we're going to do your 8 later, but I'm not ready for it yet. Okay. So just a little tidbit there. M is metacognition. There are certain brain-based strategies that we want to infuse in teaching of our making rectangles. When I said making rectangles is not a unit, making rectangles can fit with all of our units. I'm going to do a part of making rectangles every month of school. Now I'm going to skip down in my PowerPoint. This is called interleaving. So if I go back to metacognition, what I'm talking about with metacognition, there are certain instructional facilitation strategies that target how the brain learns. So I could tell I'm going to give you the strategies for making rectangles, the content today. You could all go back and do this with students. And your students could actually output a very different result in every single classroom because of user error. Because we're not utilizing some of the other facilitation strategies, one of them is getting the brain ready to learn. When I said that there's a math fix or a math fail on teaching one thing at a time, the fix to that is giving kids out of context nuggets, like making rectangles. Cognitive science calls that interleaving. That is not my word. Cognitive science calls that interleaving. Interleaving means when we're learning something over time, we want to learn nuggets of things out of context so that our brain has to work harder to try to retrieve that information. Another cognitive science strategy is called retrieval practice. If I do a making rectangles exercise in January, then I go on with my unit. In February, I come back and I do another piece of making rectangles. When I start the lesson, I will say to students, what did we do with that making rectangles last month? What do you remember? Tell me about, I use my favorite 3 words. Tell me about that making rectangles we did last month. The goal of that is to try to get them to retrieve without looking anything up. They are going to forget. Forgetting is necessary. I'm going to tell them that forgetting is necessary. And I'm going to also celebrate forgetting. However, when we engage students in one of these experiences, they don't forget. They don't forget, which is the irony of all of this. However, they will forget some of these things. So when they forget, I celebrate the forgetting, someone else remembers, or I remind them and they're like, oh yeah, it takes them right back to the experience. That process is called retrieval practice. And when they forget and they remember, it deepens the grooves in the brain that leads to long-term learning. So I'm giving you a lot. I told you this was going to be a lot today, very intense. So even if you're like, oh, making rectangles doesn't apply to me, but shoot, all of these brain-based facilitation strategies you're teaching me do apply to me. So this goes back to the M in SMART, which is metacognition. Metacognition is the category of brain-based instructional strategies. Brain-based instructional strategies. I shared a couple with you. I'm going to fuse those today. Accessibility, this is where the content is. This is where these things go. This is where these things go. Making rectangles, all of these like categorized content chunks. This means that I want to increase the complexity with kids. I'm going to say today what I have some of my 3rd graders do. And I'm going to tell you, I want your 3rd graders doing that. And you're going to be like, oh, John Lee, my 3rd graders are different. They can't. You're going to do what I'm going to tell you I do with my 3rd graders, but it's going to be very highly rigorous, highly complex. But the accessibility is going to increase even more than when we teach our regular units. So how do we get high complexity, high accessibility? That's what the A in SMART means. And that's what we're going to refer to today. Regulation and restrictions. This is kind of the behavior instructional facilitation. This comes back to really what Sherry is an expert in, the sensory and the regulation pieces. And so we know that students can't tap into learning because their ADHD gets in the way, their focus gets in the way. This is the part where we can do some 10, 15-second targeted facilitation with the whole class that's going to help Johnny refocus. And it's going to be very positive. It's going to be celebratory. And it's going to help teach Johnny how to regulate that on his own as well. See, there's so many things. You guys, teaching is complex without singling him out. Thank you, Sherry. Teaching is so complex and there are so many pieces. If you're watching this recording, you're like, for the love of everything green, can you please just get to making rectangles, Johnny? Like, just give me the content. I can't give you the content without telling you how you're going to misuse it. You are going to misuse the content if you don't understand these things. And then you might say, yeah, but now I'm so overwhelmed. Okay, we're overwhelmed anyway. If you can get overwhelmed on this stuff and break through it, it's a game changer for our stress and our overwhelm in teaching altogether. That's what I mean by transcendent. Pieces of what I'm teaching you today, you've heard before. Pieces of what I'm teaching you today, you do all the time. I do not want to discredit that. I told you we've come a long way with math instruction. However, the way we piece it all together and the accessibility piece with these reference tasks are really the game changer. I cannot say that this is being done anywhere. That's what, well, Krista is doing this. Our certified coaches are doing this. There are pockets of this. But what transcendent means is we are preparing for this instructional model that doesn't yet exist. We're creating it, we're building the plane, and we're trusting that it's going to fly. That is true transcendence. That's different than transformation. So, overview of SMART and a little tidbit of how the brain learns. Now, these are the categories of where all of the pieces I'm teaching you today go into. So making rectangles goes into accessibility. That's the content piece. Now you're going to be like, oh my gosh, John Lee, seriously? Like, you're going to do this? I am going to do this. I'm going to very quickly tell you what your action is today. The action last month was get the book, do a review. You can still do that. You can still do that. If you purchase Making Mathinaires, you get the review, you do a review, you send me a screenshot. I got free stuff coming your way. Today's action is we are having another seminar on Wednesday, December 21st. Now, someone like Krista, she's still teaching that day. That's okay. If you register for the seminar, you'll get the recording just like this. It's happening next week. It's happening live. It's going to be much more of an interactive session, and it's titled Math in a Month. So before we leave today, I'm going to tell you more about that. And I'm going to stop my screen sharing because now we are going to get to making rectangles and the process of making rectangles. So here is our first stimulus. The number 24. I hope you're not seeing that backwards. I think I set it up that we're good. Okay, good. A stimulus is just like this, the number 24. Tell me about 24. Did this with a group of kids a couple weeks ago. They're like 2 10s, 4 1s. I'm doing this with my kinders. I'm doing this with my 10th graders. Okay, so don't think, oh, this is grade level specific. No, it's going to happen quicker with 10th graders than it will with kindergartners. However, listen to how I'm going to facilitate this content prompt with 24. Okay, 24 is the first step in making rectangles. It's the number that I like to start with. It's my favorite number to start with. And this facilitation process, you're going to do over and over and over and over every month, but with a different number. Now, you could do it every week with a different number. Don't do it every day. That's where I'm going to stop you. There's going to be some restrictions here. That's the R of SMART. There's going to be some restrictions in what I'm going to tell you. So I want you to think about the facilitation part of this. You can use this with other numbers. What I'm going to do is give you the other numbers that are my favorites to use next. Okay. So first facilitation, tell me about 24. 2 10s, 4 1s. Oh, I can do 12 and 12. I can do 2 times 12. I can do blah, 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 blah. I might extend and say, what are the factors of 24? Get kids to think multiplicatively. Now I'm going to phrase that different so that there's access for all. What numbers can I multiply together to get 24? Like you guys said, 2 sets of 12. Are there other numbers I can multiply together? Now, for my older students, they might be able to rattle these off. For my younger students, they're going to be like, what are you talking about? That's where making rectangles comes in. For my older students, I'm going to say all of the numbers that you can multiply to get 24, those are the factors of the number. Now, this is beyond grade 4 because this is kind of reviewing what kids kind of already know. Those are the factors of the number. And every multiplication problem is a rectangle. Now, I'm going to pause for a minute. I'm going to type that in the chat. Every multiplication problem is a rectangle. I want kids to start to identify when they see multiplication. I want them to have a mental model of rectangle. That's what doing this every month will do for them. Now, with my kinders, I will give them a cup of blocks or tiles or some kind of square or rectangle manipulative blocks or tiles. They have to count. Now, pro ninja tip for our younger kids. I will give them a baggie or a cup, but I will not put exactly 24. See, this is another fail of our math instruction. We make things too easy and too accessible without the complexity. So like for my kinders, I'll put like 27 in a cup. I'll put 32. I'll put a little more than 24, because one of the things that I want them to do is to practice counting out 24. And I'm going to be able to assess and I'm going to be able to instruct on which students can and can't do that. So I don't want you to miss that piece. So using that manipulative, let's count out 24. Today, we are going to make rectangles using exactly 24 blocks, using exactly 24 tiles. Perfect. You can use the centimeter cubes of base 10 blocks and 24 of them. There's lots of different manipulatives, but I want the manipulatives to be squares or rectangles. So here's the step-by-step. You open up 24, tell me about. Now we're going to make rectangles. Now for our older students, we are going to, this is just graph paper. I'm going to show you graph paper, okay? As students are making rectangles, they are going to, on graph paper, they're going to draw those rectangles to scale. First grade and higher, I like 1/4 inch graph paper. Now, I like this because of the sensory piece. So if students have difficulties with dysgraphia, which is learning disability with writing, or they have fine motor issues, or they have it's like, do we really want to use smaller line graph paper? Yeah, we want to try it. We want to see what they can do with it. And then what I'm going to do is I'm going to have centimeter grid paper ready, but that's not what I'm going to start with. I'm going to have centimeter grid paper ready for students that need some larger squares. What students are going to want to do is trace. And this is why a lot of times I won't use centimeter cubes for the manipulative. I'll use bigger, like 3/4 inch cubes or tiles, because they're going to want to trace this. I don't want them to trace. I want them to use the lines and the squares on the grid paper to match up 1-to-1 the model of the 24. So once students are making rectangles, drawing rectangles, for our older students, they may not need to draw. They may just be able to say, okay, I've got a 1x24, 24x1, a 2x12, a 12x2, a da-da-da, because, you know, maybe high school students are da-da-da. Now, I am going to have students draw, but I'm going to have them do this for other numbers of rectangles. So for example, with older students, I'm going to be like, okay, here is kind of a big question. What numbers have the most rectangles that can be made? What numbers have the fewest rectangles that can be made? What numbers have square rectangles that can be made? So 24, can I make a square from using exactly 24 blocks? How square-like can I get? And let's try to draw a square using exactly 24 unit squares. Now, hold that thought for a minute, because this is all a good like interaction one. Maybe this is something I'm going to do in January when we get back. Then what I'm gonna do, I might spend 20 minutes, 30 minutes on it, you know, a day in January on this, making rectangles, and just engage kids in this facilitation. They're making, they're drawing, they're using grid paper, using tools, having conversation, blah, blah, blah. Then I'm not gonna do making rectangles again for maybe another 2 weeks or 3 weeks. When I come back, I'm gonna go through the same process, and I'm gonna tell you what numbers I also like for this. You probably can guess. 36, 48, 68, 64, 100, 12, 8, 18, 15, 19, 7, 11, 21, 23. Okay. Now, you don't have to do all of these. You can actually kind of do a bunch of them in one sitting if you're trying to make a point. Okay. Number selection is extremely important when we are teaching mathematics. So sometimes I've seen teachers where they're teaching fraction and we're using denominators of like 13. Well, I know there's probably a time and a place to have a denominator of 13, but in all honesty, if my struggling kids never see a denominator of 13, I don't care. It's probably better for them. Okay. Like, here's the thing. People ask me all the time, Jonalee, where do you get everything in your model of facilitation? I study tests. I study ACT, SAT, GMAT, state assessments. I study math assessments. There are common themes that come up in math assessments. There are typical numbers that come up in math assessments and in certain situations. So when I give you some of these like pro tips today on like, here's some of the numbers I focus on for this task, I'm not going to give you all the reasoning behind it. I want you to just trust me and be like, okay, here's the number she said to use. All right. Now you might say, yeah, but you know, what about 51? Like, I really like 51 because 51 is a number that kids think is prime, but isn't really prime. And like, maybe we could get to a rectangle thing with that. Brilliant. I didn't put 51, but 51 is one that I always use. It just didn't make that list today. Okay. So blah, 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 blah. You got it. All right. So that's kind of all like interaction one. I'm going to do interaction two in just a moment, but here's what I'm going to do. I'm going to check the chat because I know some of you have been giving some pro ninja teaching tips in the chat. Thank you for that. Sherry dropped in centimeter grid paper. When I follow up with this recording, you're going to get a whole package of resources. Hey, if you're watching the recording and you weren't here live and you've made it this far, like go buy yourself something. Good for you. Like this is important stuff and you're committed. I love it. If you're hearing this and you're watching the recording and you weren't here live, send me an email saying, I'm hearing this. I'm like, come on now, do it. All right. When I send you the link to this recording, I'm also going to send you the slide deck. I'm also going to send you any resource that I've talked about, like these cubes. I'm going to send you my favorite ones that I buy. I'm going to send you a PDF template of any of the paper resources that I've showed you. So you're going to get like an amazing like package of resources coming at you. Now, give me some time. I'm not going to send it out today. Okay. But if you do not receive these resources like in the next week, email me or check your spam. Okay. What I want to do right now is I want to open this up. I want to pause. Nobody's interrupted. You are all too humble and too gracious, but I want you to kind of give me your thoughts so far and any questions that you might have. And you can either put those in the chat or just unmute and talk to me. And that's okay too. If you're just taking it all in, that is totally fine. Absolutely and totally fine. Awesome. Excellent. I'm just looking here. Perfect. Oh, good. I was making sure nobody was in the waiting room, but we're good on that. Good. Yeah, great point, Kirk. Rectangles have so much leverage and power. And if we're looking at, I don't know if you all study like Singapore math or, it's really about this transition from concrete, touching, sensory, moving, building, creating to this like semi-concrete, pictorial, mathematical modeling, and this is where manipulatives get a bad rap. It's like, oh, Johnny, I had them use manipulatives and they still don't get it. Okay, well, you have to make the connection and you have to streamline to the semi-concrete. They have to draw it because let's face it, on testing, kids aren't going to have manipulatives. However, they always have scrap paper and they can draw rectangles. So I want to make sure that they have all of these skills. And then finally, this whole making rectangles is what's going to improve math facts. If we want kids to have quick recall of math facts, if you're an intervention specialist on here now, this is your game changer. When you have an opportunity to pull kids in small group intervention or you're working intervention in an inclusion classroom, making rectangles. I will do making rectangles at almost every single intervention session I have with a small group of kids. I'll just pick a new number and be like, oh, 36 today, make all the rectangles. Let's draw them, draw all the rectangles. How many rectangles? That's what's going to build fluency. It's the opposite of nothing wrong with flashcards. I'm not giving them a bad rap. You can flashcard, but that's going forward with multiplication. When we give them the product or the number that's the result of multiplication and ask them to come up with the factors, that's going to stick much more than the flashcard single digit multiplication. So if you have kids that are struggling with math facts, you are going to give them the making rectangles experiences, and they're going to be able to improve their math facts through making rectangles. Excellent. Perfect. All right. Here is phase 2 of making rectangles. And I know this doesn't sound like making rectangles, but it is our good old famous pizza problem. Okay. This is another one of our reference tasks. And here is the gist. I give this to students. A pizza company makes square pizzas. That's it. Now, what do I ask students? Don't miss this. I used this facilitation prompt many times today already. Tell me about. So I just say a pizza company makes square pizzas, big and small, but they're square pizzas. Tell me about this situation. And I let kids tell me. I get the student perspective on this situation. What's essential about getting the student perspective is all of our kids, this is metacognition again from SMART. This is tapping into the brain, opening up the brain to be ready to learn. Oh, you mean she cares about what I think about this square pizza company? I do. Now they have a sense of belonging. Now they're motivated. Now they're engaged. Now they're focused. That's the whole metacognition piece. I want to get the student's perspective, and then I want to use their perspective to teach the lesson. Now, even in the PowerPoint, I give you tell me about, so that you do not forget as you're facilitating this to have students tell you about. There are so many benefits to gaining the student perspective. Now, this is a game-changing tip here. What math questions can you create? Kids are going to be awful at this. It's going to be terrible. You're going to do this and it's going to be awkward and it's going to be weird. And you're going to be like, I'm never going to have kids create questions again. Please stick with it. If we can actually get kids to create good mathematical questions, we improve their achievement. So questions that my kids come up with is, how big is the biggest pizza? How small is the smallest pizza? Now, I will show kids, why do I not have it right there? John Lee, you are ridiculous. I will show kids an image of these square pizzas and I'll say, what do you see? What do you notice? What do you see? What do you notice? And then I'll go back to, sorry for the, I should have had that right here by the slide. I'll go back to now, what additional math questions can you create? And they'll create things like, oh, how many pieces are in that third pizza? How many pieces are in the sixth pizza? So if this is pizza number 1, 2, 3, or stage 1, 2, 3, how many pieces are in stage 6 pizza, a 6 by 6? Are there twice as many pieces in a 6 by 6 as a 3 by 3? Here's what I'm going to do in our chat. I'm going to type in some of my favorite questions. How many pieces in a 6 by 6? Oh, I should put pizza. Now I like are there twice as many pieces in a 6 by 6 as a 3 by 3? However, I'm going to give you another facilitation strategy. And this is how we ask questions and how we prompt. Because oftentimes the way we ask questions and prompt takes away from the creativity and the brain-based aspect for our students. It leads them to the answer. So I could ask, are there twice as many pieces in a 6 by 6 pizza as a 3 by 3? However, if I want students to have more thinking, reasoning, and sense making, so too often we focus on answer getting and solving. If I want kids to elevate their thinking, reasoning, sense making, which is exactly what I want to do, then I'm going to change my questions to start with how does or how do. Krista actually did this with one of the questions she put there. How do the crust pieces compare to the non-crust pieces? Now, I never even mentioned crust pieces, but some of you have seen this problem before. You've had interactions over time with pizza problem 100 times. You will only get the depth of your learning and instruction if you continue to interact with the same reference tasks over time. That is the same with our students. Perfect. When I said before about our gifted students need 1 to 2 interactions, our bright students need 5 to 7 interactions, our struggling kids, our kids with disabilities, our kids that don't know their math facts, struggle with number sense, estimation, those kids mathematically are going to need 60 to 100 interactions with the same thing before they know it forever. Now teachers are like, I'm a 3rd grade teacher, John Lee. How in the world do I give them 100 interactions? By doing and making rectangles every single week. That's 30 some. Then when you relate it to a different unit that you're doing on a different day, not on the making rectangles day, that's another interaction. Interactions only count when we have spaced practice. Friends, this is another brain-based strategy. You'll have this all together chunked. Another brain-based strategy is spaced practice. Making rectangles is a perfect example of how to use spaced practice to get interactions over time. But the power of the multiple interactions is when there is space in between of out of context content. That's the interleaving. Then when I come back to it, I ask students to tell me about the previous interaction, which is the retrieval practice. Now, this is brain-based strategies, not just for mathematics, it's for everything we teach and learn. But I'm telling you how I do it with mathematics. So if we need that many interactions, there's a couple of answers to that. For my third grade teacher, one is, okay, you pick 3 reference tasks and relate everything you do to these 3 things. Actually, for all of you today, pick 1, making rectangles. Everything you do from now on, not everything, because if, you know, we have other reference tasks, like if you're teaching integers, there's a better reference task for operations with positive and negative numbers. Okay. I'm not going to stretch making rectangles to try to like connect to integers. That's why we have a handful of reference tasks, because although making rectangles will bring in many of our standards, I'm not going to say all. Okay. But I'm going to go back to the chat here, because Ninja Chip, how does, how do, start a question with that. So instead of, are there twice as many pieces of pizza in stage 6 as stage 3? I'm going to ask, how does the number of total pieces of pizza in stage 6 or in the 6x6 relate or compare to the number of pieces in the stage 3? By starting with how does, it forces us to design a question that doesn't lead students to thinking twice as many or half as much. They would have to make that connection. By starting this question with how does, it leaves it much more open for creativity so that students can think, reason, and sense make. And there can be a lot more answers to this question than, are there twice as many in stage 6 as stage 3? There's really 2 answers to that. Yes, no. I mean, I could follow up with why and how do you know? But you see how starting a question with how does, how do is going to transform the type of responses I get from students. Now, what I can do at this interaction is, if I have time in my classroom, I can actually give kids an opportunity, again, with blocks, to make square pizzas, again, with 1/4-inch grit paper, to draw their square pizzas, again, centimeter grid paper, to draw their square pizzas. And then we can generate additional questions. We've done the sensory, we've done the drawing, we've done the concrete, semi-concrete. And here is the abstract, my friends. Let me give you some more questions that are going to blow your mind. Make a square pizza with exactly 24 pieces. Okay, remember the making rectangles we did, 24? It's going to come back in. Here's another interaction with that. I cannot do it with blocks because I can't break them into parts. The closest I can get to a square like is 4x6, 6x4. Okay. Now that takes us, that's a little salty. I call this a little salty. We can lead a horse to water, but can't make it drink. I can make a horse drink with a salt lick. So when I plan lessons for my students, I can lead them to learning. I can't make them learn. Yes, I can. If I make them thirsty, what is the salt lick? These prompts that I'm giving you today are the salt licks. So what are your salt licks? What are the good prompts that you can give? They're going to lead to thinking, reasoning, and sense making. They're going to lead to focus and engagement. They're going to lead to curiosity and creativity. This is it. And this is all based on just making rectangles. Now, Krista brought up a good point. How do the number of crust pieces relate to the total pieces in any size pizza. So now it's like, oh, there's some crust pieces. They're on the edge. The ones in the middle, the no crust pieces. What are the relationships? Da, 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 da. Okay, this is crazy. If you teach ratio and fraction, you could phrase that differently. What is the ratio of, let me do this. What is the ratio of crust to non-crust pieces in any size pizza? I put ratio on. Look at me. Ratio. Okay. This could launch your lesson on part-to-part ratio, or what would be a question that would target part to whole? How do the number of crust pieces relate to the total pieces of pizza? So now I can actually bring in fraction ratio concepts. What percent of these large pizzas are crust pieces? And how does that percent change over time? Oh my gosh, my friends, if you teach 7th grade and you're looking at percent change, you're actually looking at, as these pizzas grow, how do the number of crust pieces grow? Do they grow in a linear or nonlinear way? How many crust pieces are in the next piece of pizza? And what's the percent increase of crust pieces? How many pieces of pizza are in a 100 by 100? And how many pieces are in an N by N pizza? Friends, we've already moved into this idea of rate and function. Most of these questions I will also ask my 5, 6, 7-year-old students as well. Even the one with make a square with 24 pieces. Now, let me stop sharing for a moment. Thoughts, comments, questions? Going through the chat just to make sure I didn't miss anything. Excellent. So now, skip ahead to, another 3 weeks out. Maybe it's March and you're like, oh, I got to go back to that making rectangles thing. Remember that workshop I went to? And oh, I still have that recording. I could watch the video again. Oh, that's right. She sent us those resources. And oh, okay, let's do this again. Let's do this again. So third interaction. Here is what I like to do. Now, I'm going to break this apart a little bit because I have some special groups of kinders, first graders. At this point in the year, they're getting really good at what numbers make squares. Okay, we focus on that a lot. They're also getting really good at taking any whole number within 100 and telling me if it has lots of rectangles or little rectangles, because we've done so much of making rectangles. So with my kinder first graders, we might do it another day where they are finding all the numbers and we're going to chart all the numbers that make lots of rectangles. 24, 36, 48, 64, da, da, da. Oh, we're going to chart the numbers that only make 2 rectangles. 17, 1 by 17, 17 by 1, 11, 11 by 1, 1 by 11. And I'm doing this with 5 and 6-year-olds. Okay. Which numbers make exactly 2 rectangles? Now I know this is like, whoa, by the time we're in 4th grade, kids have to know prime numbers. That is the exact definition of a prime number. A prime number is a whole number here that can only have exactly 2 rectangles made from that many blocks or that many squares with whole number side lengths. 24 is not prime because it has more than 2 rectangles. The number 7 is prime because it can make a 7 by 1, a 1 by 7. That's it. Exactly 2 rectangles. Is the number 1 prime? Well, I can make a 1 by 1 and a 1 by 1. Essentially, that's the same. That's only 1 rectangle. It's not 2. Prime numbers have to have exactly 2 rectangles, exactly 2. No more than 2, no less than 2, meaning 1. That is essentially why 1 is not prime. It's only 1 rectangle. Okay. Sherry, I saw you pop on. Did you want to say something?
Sorry, I have been incognito today. I've had a cat very disruptive today. So
that's okay.
He wanted to be in the picture and I was preventing that.
No,
so,
that's no problem.
Anyway,
I just saw your face and I thought maybe you wanted to say something.
Not anything in particular. I don't know if you were trying to reach me a little bit ago. Sorry, I got distracted by him. But I mentioned proprioception, vestibular, and kinesthetic. Can everybody put in the chat any of those words that you have not heard of before?
Probably all of them. Come on, Sherry.
Proprioceptive, kinesthetic, and vestibular. Is there any of those words that are, I have no idea what they mean? Because they are essential sensory components that we don't think of when we think of when you think of the senses, you think of the 5 main ones. There are actually 5 more senses, but the ones that I wanted to make sure that you were aware of today are the proprioception, vestibular, and kinesthetic and vestibular. So, okay, so, all right. May I do my my 8 now?
This is perfect. This is perfect. Yep, right. This is perfect because I want us to kind of refocus, because I'm going to give a quick stage 3 and stage 4 so we can see kind of the ultimate of where these making rectangles go. And then I've got your final action taking and a little more information about December 31st. And people may not want to put their video on, and that's okay. They may not be in a place to be able to do that. So we're not going to.
And that's okay. But I do want them to stand up.
Perfect. Yep.
We need to stand up to do this because it's going to be much more effective and you're going to get much more of a response. So if you can, or you don't have to. All right. Thank you, Krista.
My corner today.
Thank you, John Lee. You're going to put your hands up over your head. Put your hands up over your head. And you're going to try and squeeze your abdomen together and try and touch the sky. That tightening that you felt, that core compression, you are using your muscles to create a stimulus to your brain that says, oh, I need to have my muscles prepared for movement. So that's what the idea of the contraction and a release is for. That contraction is preparing the muscles to tell the bones where to move. Okay, so we're actually going to do the 8 now. So we're going to do this again. Hands out in front of you. Keep your palms away from you and wrap your fingers, interlace your fingers together. Up and over your head. So you should have that same feeling in your abdomen where you were tightening them because we were trying to squeeze. Now, I want you to write with full arm movement the number 8. What did you notice? So I want you to write in the chat what you noticed about yourself as you did that movement. The angle of your hands with this activity is quite important. But come on, what did you notice? I'm not seeing anything coming in the chat. Or you can unmute and just shout it out. But for John Lee's chat, I thought it would be good to go there. Okay, so your hands in the position that they were in are quite important, and interlacing them together. What you are doing is you are telling your shoulder muscles, your hands are ready for grasping a pencil. whether it's the left hand or the right hand, this position, because your hands need to be away from you, okay? Interlacing your hands together gets both sides of the brain working, okay? So what proprioception is, if we were just thinking about the shoulder joint, and it's a circular joint, it's a socket, okay? As you are doing the number 8 and you're coming down, you're coming around, you're telling the muscles on the inside to go that way and the muscles on the outside to relax so that the muscles on the inside can pull that way. You come around and you come back out. That sense of how much pressure for the muscle to pull in and relax on one side and then pull in and relax on the other side is called proprioception. Now, I went into a little bit more technical term than you may have heard before, but basically, if you want to think about it this way, it's the push and pull on the joint. So we're going to go to the knee just a moment. The knee is a little bit easier because it's just a hinge. As you're running, you got push the 2 bones on the bottom of your leg and the 1 bone on the top of your leg, push together, pull apart, push together, pull apart, push together, pull apart. There is nerves that are interacting with your muscles that are saying, it's time to push, it's time to pull. That proprioception is how your body works together so that you don't over or under move a muscle. So when you pull a muscle, those muscles aren't working correct. That signal isn't helping and working correctly. So what you've heard, maybe do some heavy lifting or some heavy activities with the kids. All they're doing is trying to get those joints to get that push and pull movement. That push and pull movement is essential for writing. So if you have kids that are struggling with writing, you need to wake up the shoulders and the brain so that the hands can work, because it all starts up here and there's a nerve circuit that goes down to your fingers and back. They all go through the shoulder. If you don't get the shoulder working, you're not going to get everything else working. And also, if you don't get the entire body tightening up, like that initial pose where we're tightening the abdomen, if you don't have those muscles in your belly tight, your shoulder isn't going to work right, because you need the center tight so that the end can move.
Now, if you are an intervention,
sorry, I'm going to pause there just because I don't want to go on to the other 2 until I'm sure you understand that.
Okay, let's just do the one today. Let's just do the one today, because I want to make this connection to SMART. So teaching SMART, that is the sensory, what Sherry is talking about. Sensory is more than our 5 senses. Ultimately, movement is a very important part of sensory. And when we have our students, if you're an intervention specialist or classroom teacher, whatever it is, but especially an intervention specialist, this is essential as you're working with kids that have any type of disability, disorder, etc. It's also important for all kids. Sherry, say your quote about harms none.
Benefits all, harms none. And that is from the International Dyslexia Association, not me.
Perfect. So, and if you are a teacher that you have dyslexic, dysgraphic, dyscalculia kids, these kids with these specific learning disabilities, or kids that are not diagnosed, these exercises benefit all, harm none. These exercises that are going to take as little as 30 seconds are so essential to open up the brain so that the brain is ready to learn, ready to engage, and ready to focus. Now, Sherry, this will be some incentive for everybody to come back next month. So Sherry, I'm actually going to put you at maybe at the beginning of next month to start on the other 2 so that we can embed this in next month's task. Excellent, excellent, excellent. Wow.
So if you are interested in learning a little bit more about the whole idea of proprioception and kinesthetic and these 30-second bursts beyond math in general, I have something I'd like to share with you as well.
Perfect. Can you put that in the chat?
Yes, ma'am.
Awesome sauce.
Now, I know I'm hitting you really hard the first day back to school, but on January 2nd, I am, oops, that is not the right link. I'm sorry.
That's okay.
And so that one is the link that you want. I was thinking something else. January 2nd, I am doing a 5-day event. You can join for free. You can get a little extra by paying a little bit more. If you need CEUs, you do want to pay a little bit more. And this event is going to really delve into the idea of what it is that causes struggles with writing. And we really are going to focus on 30-second activities beyond those two that I just showed you to help kids engage in the classroom. I'm getting that link here shortly.
Perfect. We'll wait for you to drop
So
that in.
January 2nd is the next time we're running it.
Excellent.
Copy. Paste. So I'm giving you just my homepage. The 5-day challenge is what you want to click on. And that is right there on the top and in the menu bar. So sherrydotterer.com is my page, and then the 5-day challenge. And the next one is going to be January 2nd.
Excellent. So I'm going to share my screen. I'm going to take us back to just to kind of review, and then I'm going to give you the third and fourth phases of questions for making rectangles. There are so many deficits because of the fails we've talked about. Hopefully, between Sherry and I both have given you some quick, like ninja tip fixes. But I want to zoom out for a minute. They all fall into one of these 5 categories. And the way that we deliver making rectangle, excuse me, is over time, interactions over time, which is called space practice, out of context from what we're currently studying, but then connected to what we're studying. And then allowing students to have retrieval practice exercises to deepen the grooves in the brain for long-term learning. Now, I'm going to give you, let me find it. Sorry for the scrolling here. Oh, come on, John Lee. You're going to get this whole PowerPoint that has all of these references in it. Oh, son of a gun. I'll have to put that slide in. I didn't put it in there and I'm looking for it. Okay. So here's what I'm going to do next. And I do this with my 2nd graders all the way up to high school. Even though you're going to be like, this isn't in my standard. Here is the next stimulus. Okay. Square root of 24. See, one of our fails in math instruction is we do not teach beyond enough. Now, what you might say is, yeah, but John Lee, I have to directly relate this to my standards. In 3rd grade, we have to know same area of rectangles, different perimeters, same perimeter, different areas. The way that I'm going to describe the square root symbol is that we have a square pizza that has 24 pieces. What are the dimensions of the pizza? Now, here's my instruction that I will give these kiddos. I will show them the pattern. Square root of 4 is 2. Square root of 16 is, I'm going to have them guess because they're going to guess 8. That's going to be a best wrong answer. But I'm going to tell them square root of 16 is 4. Square root of 36, best wrong answer, 18. Correct answer, 6. Through showing students that pattern, I'm going to tell them this means that you have a square pizza with this many pieces What is the side length? So now we're relating this to square pizzas. We're relating this back to making rectangles. What rectangles can I make that are the most square? What I do for students before they study area is I call each of these numbers 16, 36, 4, 24, the array number. After they study area, these are the areas of rectangles. What are the dimensions of rectangles? So even though I can't physically make a square pizza with 24 pieces, on grid paper, could I make parts of pieces? Or in other words, if the area of a square, is 24 square units. If the area of a square is 24 square units, what is the side length? Now, even kids as young as my third graders, same with my high school students, they'll be like, okay, so maybe it's like 4.5. So now I have to know how to multiply 4.5 times 4.5 to be able to see if I get an area, if I get the number 24. This is going to lead us to our next lesson in January, our next Saturday in January, where we're going to focus on paper folding, fraction, but we're going to relate it back to this making rectangles. Also in January, I'm going to extend the fact fluency and how to use the multiplication chart as a dimension chart. So the multiplication chart, the numbers on the top and on the side are the dimensions of rectangles, and the numbers that are the multiplication products are the array numbers or the area numbers. So now I can leverage multiplication charts and give meaning for kids. Now in January, we're going to have another Saturday math session. That is exactly what our focus is going to be for January. However, I do not want you to miss this. We are having a 3-hour session on Wednesday, December 21st. Even if you can't attend, you're going to get the entire recording. It is called Math in a Month. It is a Jumpstart January. The way to register and find out all the information is to go to mindsonmath.com. It's called Math in a Month. It will be a 3-hour session. It will be recorded. You will get all of the resources that go with it on how to teach math for 20 minutes a day in 23 days, starting January 3rd or whenever you go back. So the 23 days comes from January 3rd to February 3rd. For me, there are 23 of my school days. So for 20 minutes a day, how can we do, and making rectangles is going to be in there. What do we do for 20 minutes a day for 23 days? How do we teach math in a month that's going to get the majority of my standards? Like literally, you could teach almost all of your standards for 20 minutes a day in 23 days. You're going to get the day 1, day 2, day 3, day 4, the 23-day slide deck and teacher guide. This is a paid session, typically $197. It is not $197. Typically, to get access to the replay recording, the slide deck, and the teacher guide, we typically price these at $297. It is not $97. The discounted price for this, $47 per teacher. You can register at mindsonmath.com. If you're still teaching like Krista is on Wednesday, you're in the classroom with kids, purchase, get the package later in the recording. December 21st, 10 a.m. to 1 p.m. Eastern time. It will be recorded. You can register and get all the information at Minds on Math. The recording and this training will be sold later for $297, the whole package. You can get it if you register before Wednesday and share this link with anybody, $47 per person. That gives you complete access to the link. You got your own personal link to the video and the slide deck, the teacher guide, and all of the instructional resources to teach math in a month. The math in a month doesn't have to be in January. It could be any month. It could be the first month of school. It could be February. I'm doing this math in a month in January. I have a group of kindergartners, second grade, third grade, fifth grade, eighth grade. And I'm doing this same math in a month. It's the same slide deck for all my kids. I'm doing this math in a month for all of those grade levels in January. I'm giving you my lesson plans and recording the session so that I can share with you the facilitation of my lesson plans. So if you want to register, if you want to share with your principals, your curriculum people, your colleagues, go to mindsonmath.com and you will get the discounted rate, which will go away after Tuesday. So you want to register before Tuesday. You can pay online. The package will be available for $297 after Wednesday if you want the recording and all of the resources. So jump in on this and let your colleagues know. Friends, I've gone 3 minutes past my time. I do want to value your time on this Saturday. Here's what I'm going to do today, and I typically don't have a lot of time extra on Saturdays, but today I'm going to stay on for about another 15 minutes for additional Q&A or conversation. If you have thoughts, questions, whatever you want, I'm going to stay on after I end the call, but I'm going to stop the recording and give us our final goodbye until the new year. Hopefully I will see you in January at our next Saturday session. But friends, Wednesday's package is a deal that you do not want to miss. Send your friends to mindsonmath.com. I'm going to stop our recording.